So I'm sure you've seen cranes before, and you might have even seen railroad cranes before. We've never seen one like this. This is the Detroit River Tunnel Wrecker Crane #1. I'm Darren, and this is the Industrial Revolution. We'll come back to the crane here in a minute, and we even get to take a quick peek inside the cab during operation. But first, let's dispense with a common misconception. Everyone sees the name on the side and thinks this tunnel crane was used to actually construct the Detroit River Tunnel, but it wasn't. The tunnel construction was actually way more interesting than that. More commonly known as the Michigan Central Railway Tunnel, it was the first underwater immersed tube tunnel design ever built. The tunnel was made of pre-made segments, made entirely on land, then floated into place. Once in place, they were sunk into trenches, connected together, and buried. While researching this video and looking into tunnel technology, I fell down the rabbit hole. As is so common, when you start looking at Industrial Revolution structural engineering feats, it led straight to the Brunel family. Of course. The construction of the Michigan Central Railroad Tunnel was an amazing, innovative way to build a tunnel in the mud and silt at the bottom of the river, but that's not our story today. If you want to see a video about this tunnel or other tunneling technologies, let me know in the comments. Instead, this is a video about a unique tunnel crane. They didn't need our railroad crane to build the tunnel, but they were pretty certain that they'd need it inside at some point. The tunnel is made up of two parallel tubes. Each one just barely holds a single train. Here in the interior of the tunnel, you can see that you have standard gauge tracks. On each side of the train, a narrow, elevated walkway runs on each side for access in the event there's a problem. That's important here. Over on the side, you can see there's a third rail, like you see today on many subway systems. This is a 650-volt DC under-running third rail, so the power is on the bottom side, not the top. It's safer for workers, but still, I wouldn't want to step on it. Steam locomotives were used everywhere outside this tunnel, but no steam locomotives were allowed inside. Apparently, train passengers and crews like to breathe or something, so for the interior, they only allowed custom electric locomotives. These were called tunnel motor locomotives, and it was their job to pull the trains through the tunnel. They'd uncouple the steam locomotive on one side of the river, it'd pull away, and then they'd connect the tunnel motor locomotive to go through the tunnel. Once it got to the far side, they'd decouple that, and a different steam locomotive, which had just dropped off its own train to go through the tunnel the other way, would pick up this train and continue its journey. The trains didn't stop long, they just changed locomotives. As this construction photo shows, you can see it's pretty cramped in here. But what if a train broke down? Or worse yet, what if it derailed or there was a fire? What if it closed down the tunnel? The Detroit-Windsor crossing was, and still is today, one of the busiest international trade crossings in North America, currently handling about 25% of all commercial border traffic. If you close the tunnel, even briefly, international trade grinds to a halt. Costs add up fast, costing millions of dollars an hour. Unless, of course, you have a backup plan. If you don't live in the Great Lakes area, you probably don't realize just how huge it is, or how much of a challenge it could be to navigate. In 1910, when the Michigan Central Tunnel was built, there was already a single-track, single-tube railroad tunnel under the St. Clair River, about 60 miles, 100 kilometers north. It added a few hours to the trip, of course, but it was already running at full capacity when the Detroit Tunnel was built, so there's no help there. To get around to the east, you had to go about 370 miles, or 600 kilometers, starting by going south to Toledo, then east through Cleveland, and over John Roebling's record-breaking bridge over the Niagara River. Or you could always head north, going 350 miles, or 560 kilometers, crossing the Mackinac Straits by ferry, then going over the St. Mary's River by bridge. Then, of course, you still had to get to wherever you were headed in Canada, which likely added even more miles. You had no good options. There really was no backup at all. you had to reopen the tunnel, and you had to reopen it fast. That's exactly what our record crane was made for. The crane was custom built by Industrial Works from Bay City, Michigan. Much smaller than typical railroad record cranes, this crane had to operate entirely within the 18-foot height of the tunnel. Today, it's operating on steam supplied by the 1873 Torch Lake locomotive, which is the oldest regularly scheduled steam locomotive operating in the U.S. today. Incidentally, that's Henry Ford's favorite locomotive, the Detroit and Lima Northern No. 7, passing by in the background. I have a video on the story of Torch Lake and the other locomotives making cameo appearances in this video today in the description. Even if you haven't heard of Industrial Works before, you've certainly seen their work. In addition to being a major supplier of heavy-duty railroad cranes, they also provided rail-mounted cranes and excavators for the Panama Canal at about the same time as the Detroit River Tunnel was being built. Everything at the Panama Canal, of course, was steam-powered, which worked great out in the jungle, but coal-fired steam power wasn't going to work for the tunnel crane. In the tunnel, and in parts of adjacent yards at both ends, the crane would use electricity for everything. We'll come back to that. Outside the tunnel, once it moved away from the tunnel area, it operated on steam, but it did need some help. The crane doesn't actually have a boiler of its own. That signal you just heard was the crane operator asking the Torch Lake engineer to move. The crane actually can move itself on electricity, of course, and could technically move itself on steam. I say technically because, although the crane can power its wheels through a geared system when running on steam, it'd also have to drag the heavy Torch Lake along with it, which is just a bit much for this crane. For railroads which needed to do this regularly, there were standalone boiler cars. Think of it essentially like a tank engine, but without all the cylinders, piston, driver wheels, etc. It was just a boiler, firebox, and water tank, which you could couple to the crane when needed. They don't have one of those here, though, so instead, Torch Lake has to do all the forward and backward work. What it's doing here today, though, the Torch Lake engineer told me that the locomotive really isn't working very hard, basically just sitting at a bare simmer. The engineer still needs to pay attention to the boiler and keep the fire going, but it's hardly using any steam at all, which makes sense, especially since the crane's not working very hard today either. They don't even need to fill up the water during the day. And while we're talking about steam, let's look at that connection between the crane and the locomotive. Out the front of the Torch Lake's boiler is a pipe connected to a flexible hose which goes to the crane. You can see here where it connects into this pipe. The pipe goes straight up, staying well clear of the crane's rotating cab, then turns forward. That pipe goes over the exact center of the crane cab's rotation, then comes straight down to provide steam through a rotary steam joint. That joint means the cab can rotate around in any direction and still receive steam. And of course, you have to vent the steam too. It vents out the back, one pipe for each of the two cylinders. There's no boiler, so there's no stack. Once the crane has steam, it's routed to a pair of cylinders, one on each side, which drives a main shaft to power everything else. You can see the valve gear just above the cylinder. It works just like any double-acting steam engine cylinder, just like those on steam locomotives. Before we go into the cab, let's take a look at what the crane can actually do. First, we always need power. We've covered the steam power when it's outside the tunnel, but what about inside the tunnel? At the back of the cab, there's a large electric motor which, when inside the tunnel, or on the adjacent yards, was powered by a third rail. That motor would drive the same main drive shaft as the steam pistons. The electrical pickups were removed at some point, and there's no third rail here anyway, so that motor's no longer in use. Sometimes, an accident in the tunnel could damage the third rail, or maybe risk shorting it out. That would make it dangerous to leave it powered while people were working down there, so they'd cut the electrical power to that section. Since the crane still needed power, and they really didn't want to run steam in the tunnel, they had what were essentially massive jumper cables. People would hook these up to the crane and then drag these huge, heavy cables up the tunnel to the point where they did have power and connect to the 650-volt DC third rail. This would allow the crane to actually run on electricity, even with no electricity in that section. So we have power, either electric or steam, driving that main drive shaft. So what can you do with it? Although the electric pickups have been removed, the outriggers actually do remain. You can see them here in their retracted positions. They could have been extended to the sides to add a lot of stability to the crane when it was outside the tunnel. Inside the tunnel, of course, there really wasn't any room for them, but the crane didn't need to reach to the side much either. Like all cranes, maximum capacity is a function of how far the boom is reaching and whether or not the outriggers are extended. To prevent cranes from rolling over, most, including this one, comes with a plaque stating the maximums. With outriggers, 120 tons at 17-foot radius, for example, all the way down to 16 tons at a 20-foot radius without outriggers. Since the crane couldn't physically extend the outriggers in the tunnel, it was limited to the smaller loads of 16 to 22 tons inside the tunnel, depending on how far the boom was extended. They had two cranes working at the tunnel, with number 1 here stationed on the Detroit side and number 2 across the river in Windsor. Between them, they'd try to lift the equipment back on the rails. If both cranes could reach, doing a tandem lift, they'd double their lifting capacity to as much as 44 tons. With the help of short lifts, hydraulic jacks, very careful manipulation, and often a lot of creativity, they could get almost anything out of the tunnel. But if there was an especially heavy wreck to remove, they'd have to either take it out in pieces or drag it inch by inch through potentially a mile or more of tunnel. Cranes, no matter the size, have 3 main functions. They need to lift the load with a cable, pulling the cable up and down. They need to raise and lower the boom, which is mostly to reach over the top of the load. The closer the load is to the crane, the more stable it is and the more it can lift. They also need to swivel, although this would have been pretty limited inside the tunnel. Outside the tunnel, though, around the yards on both ends of the tunnel, they did have room, so the crane could operate there on electricity, or, if needed, on steam. The other thing they need to do is move. Remember that, on steam here in Greenfield Village, the steam locomotive has to do the actual moving. For on electric power, there's a geared shaft going down through the center of the cab, which can drive the crane forward and back under its own power. They don't have a third rail here, though, so we'll stick with steam. You can see the operator running lots of levers here, but if you think about it like a steam locomotive, it really helps to understand what's going on. You have a throttle, which is just a steam valve that controls the speed, and a reverser, which controls the direction it runs. That's all just like on a steam locomotive. Then you have a bunch of other levers that engage a clutch up against the drive shaft to actually do the work, running the cable, the boom, the rotation, and the drive. Let's go take a look inside. So this video is made possible thanks to the generosity of people helping out here on YouTube with super thanks, or through memberships at patreon.com/industrialrevolution, or by clicking the join button here. If you're able to help out, I appreciate it. If not, I fully understand. In any case, let's get back to the video. So no one's ever allowed in here, and when they're not running it, they keep it closed up, and you can't see inside. It looks like there's a lot, but think about what controls are actually needed. The large wheel on the right is the throttle. It gives you a lot of control over the speed, which you need for precise lifting and placement. The rest of these levers are here to engage the heavy mechanical clutches onto that central shaft to actually run the lifting drum, the boom hoist, the rotation, or the drive. Because they all draw power from that single spinning shaft, and you're typically trying to lift or move with maximum precision, the operator usually only engages one lever at a time. You can actually see that spinning drive shaft down under the floor. That's the shaft which, whether it's powered by steam pistons or the electric motor, that's what actually powers everything else. And that's about all that's in here. This amazing crane is always on exhibit here at Greenfield Village in Dearborn, Michigan. But unfortunately, it only operates maybe one weekend a year. They do, however, almost always operate at least one steam locomotive, like Edison there in the background. This crane was really far ahead of its time. One of the few record cranes on railroads that could actually run under its own power. It was able to run on either steam or electricity. And it was custom built to work in the close confines of the Detroit River Railroad Tunnel. And because of that, this crane, this is the Industrial Revolution. Hey, thanks for watching. Hope you enjoyed it. If you could help out the channel, I like, share, subscribe, and comment. I love reading the comments. Usually respond to those pretty quickly. I have a playlist here if you want to see more railroad videos. Also, YouTube thinks that video up there is one that you'll really like watching next. Again, thanks for watching, and I'll see you next time.